Okay, guys, so here's part 2 of your review. So in part 2, we're going to talk about the accuracy of instruments. When you're looking at something, how do you know what is going to be more accurate? And just as a reminder, accuracy refers to hitting the mark, or being correct. Accuracy, the history of it literally comes from archers who would take aim at what looks like a dartboard kind of thing, and they would try to hit the center, the bullseye. So accuracy, it means to hit the mark or to be correct. So when we're looking at instruments, some instruments are created more accurate than others. So for example, if we have a beaker and a graduated cylinder, this picture of the graduated cylinder makes it look a little smushed. I apologize, but I needed them to be on the same screen. So when we're looking at the beaker versus the graduated cylinder, the thing that you want to keep in mind are these tick marks that are right here. Okay, so one good rule of thumb is the more tick marks you have, an instrument have, so more tick marks mean more accurate, okay, or it's going to be more precise. It can measure to a smaller degree of certainty. So for example, if we look here, we see 100 and 200 and a line in between. So that line must be 150. Let me use a different color there. So that must be 150. So 200, 250, 300, 350. The space between each is worth 50 milliliters every time. If we look here, in between 50 and 100 is a halfway mark, so that's 75. And then we have smaller spaces that divide it up even smaller. But if we were to look at even just that, the space between that is 25 milliliters. So it can measure to a greater degree of certainty. And that's what's important when you're looking for. So when we're looking at these, graduated cylinders are always more accurate, okay? Graduated cylinders are more accurate than beakers, okay? One thing to keep in mind is that you can only compare instruments that are going to measure the same thing. So beakers and graduated cylinders all measure volume, which is the space it takes up, okay? So the matter, the atoms, whatever liquid is inside of it, it's measuring how much space it takes up. And so these are measuring volume, and they're using the units of milliliters, okay, which is often abbreviated as lowercase m, capital L. Anytime you see liter, you're talking about volume, okay? Another common instrument is a scale. So when you're looking at a scale, how do you know which one is going to be a more accurate instrument to use? Well, here you're going to be looking at the number of decimals after the number of digits after the decimal. So here we see the number 1.102. This means that I have 3 numbers after my decimal, whereas if I look at this screen on this scale, I see the number 500.00, which is 2 decimals. Similarly to the graduated cylinder and the beaker, the more decimals you have, so more decimals equals more accurate. So I can see if I really need a high degree of accuracy in my experiment, I'm going to want to use the scale number 1. But if I am okay with a little bit of uncertainty, it doesn't have to be exactly perfect, I might use number 2. Okay, there are scales like the first one, which are accurate to 3 decimal places in another chemistry room where they do the AP chemistry because some of their labs need to be more precise. So that's kind of what we're looking at there. And one question that we've seen on warm-ups is, let's say we have student A and we have student B. Okay, student A is measuring volume of an object and the mass of an object. Oh, that reminds me, I forgot to talk about what a scale measures. Remember, a scale measures mass. This is the amount of matter. Okay, it's very, very similar to weight. Okay, on Earth, mass is equal to weight. Okay, however, but on the moon, where the gravity is smaller, mass does not equal weight. Okay, so that's one thing to keep in mind. And we use the unit of grams, which is abbreviated as a lowercase g, which we can actually see that. There's a G right there on the scale. And this is pointing towards its unit on the side, which it's currently being measured in ounces. It looks like we would want to make sure we hit the unit button here to move it up to the grams. Okay, so beakers and graduated cylinders measure volume, scales measure mass. So let's say they're trying to get the density, and they're both measuring volume and mass, because they're going to use those numbers to calculate the density of whatever object it is they're measuring. Well, if student A uses or measures the volume to be 50 milliliters and the mass to be 4.3 grams, and student B measures the volume to be 50.4 milliliters and the mass to be 4.32 grams, and we ask ourselves which one is using the more accurate instrumentation, okay, assuming that they are taking their numbers correctly and are reading their instruments correctly, then we would notice that this has 2 decimal places compared to this one. So we already have a more accurate balance being used by student B. And if we're looking at volume, we see that this has 1 decimal, this has 0 decimal, or numbers after a decimal place. So this one is most likely using a graduated cylinder compared to student A, who's most likely using a beaker. So this person used a more accurate scale plus a graduated cylinder, whereas this one probably used a beaker plus a scale, but it wasn't as good of a scale. And so that's something that we want to keep in mind for our test, or these kind of concepts. So keep in mind, how do I tell the accuracy? So remember, in video 1, my apologies, in video 1 we talk about significant figures, and in video 2 we have now talked about the accuracy of the instruments. So make your way to video part 3 for the next part.